Welcome to the Homework Hotline at Emily Griffith High School and DPStv 22. I'm Whitney McCabe.
And I'm Becca Hendricks.
We're teachers here at Emily Griffith High School, and I've been teaching language arts for 7 years.
I've been teaching math at the middle school and the high school level for about 6 years. Emily Griffith is one of the sponsors of our Homework Hotline show, and it's on DPStv 22, that's channel 22 on Comcast.
Each week on Wednesdays, we're here at DPStv 22 studio at Emily Griffith Technical College, and we're here to help you with your homework questions.
We know how difficult it can be to do your homework on your own sometimes, so we're here to answer your questions.
Reach out to us live by calling 720-423-4980. You can call, text, email, or contact us via Twitter with your homework questions, and we'll be happy to help you.
The text number is 970-680-3771, and we'll be on every Wednesday from 4 to 5 p.m.
Or you can follow us on Twitter and post your questions at EG Homework. So, Becca, how was your day?
It was really fantastic. It was really good.
Great.
Do we have any callers? All right, well, while we wait for some callers, let's go ahead and look at a Back to Basics clip that Whitney did about homophones on 2, 2, and 2.
For our first Back to Basics lesson, we're going to talk about homophones, and there's various homophones. Basically what they mean are words that sound the same, homo meaning same, phone meaning sound. So first we're just going to talk about the different types of the word to. To means in relation to or in addition to. The one with two O's you can remember because it has an excess of O's. It also means also and as well. The two with the W is the number 2. And one way that you can maybe remember this is with this sentence, which uses all three. Go to the store and buy 2 boxes of cereal so your sister can have one too as well.
Tricky sometimes.
And if anyone has any questions about other homophones or other confusing words with same spelling or different spelling, feel free to call us at any time.
Please do. We'd love to answer your questions. No callers?
Okay.
Talk about the Bowl, talk about the Super Bowl. Have you looked at Broncos?
Today I took some students to see Hamlet at the Buell Theater for the DPS Performing Arts Center that's going on for the next few days. If that's something that you're interested in, you might check that out. It's a great theater company and they put on a great show.
That's great. That's awesome that you did that. Very cool, Whitney. Well, since we don't have any callers right now, we don't have any Twitter questions, which, by the way, you can tweet your questions to us at EG Homework. Since we don't have any, let's go to another Back to Basics video. This one is on fractions.
We're going to look at some problems today called fractions of problems. So for example, if we were to do 3/4 of 40, when you're looking at a problem like this, it's important to understand the parts of the problem. The 40 is the whole. The 3 is our numerator, which tells us how many pieces we're referring to of our whole. And then our denominator tells us how many pieces our whole is split into. So because the denominator tells us how many pieces the whole is split into, we know that the whole is 40 and it's split into 4 pieces. If our 40, our whole, is split into 4 pieces, that means that each one of these pieces would be equal to 10. And you can even check to add them up to see if they do still equal 40. So that is your whole. The 3, the numerator, tells us how many pieces we're referring to. So in that case, that means that we're referring to 3 out of the 4 pieces. So these 3 pieces are our 3/4. These 3 pieces each are 10, and they add up to equal 30, so that means that 3/4 of 40 is 30. You can also think about this in not just like a pi fraction, but also a number line. So our whole, again, is 40, so I have a number line from 0 to 40, and our denominator still tells us the same thing, that it's split into 4 equal pieces. So if I split this 40 into 4 equal pieces, it means that each piece will have to equal 10. And again, our numerator of 3 tells us how many pieces we're referring to. So that means 3 out of these 4 pieces. So again, 10 plus 10 plus 10 adds up to give us 30. We can look at another example, 7/8 of 24. It works the same way. Our whole is 24, which means that the whole needs to add up to equal 24. 8 tells us how many pieces are in one whole. So this is split into 8 pieces. So if 24 is split into 8 pieces, that means that each piece will have to be 3. And then the numerator tells us that we're referring to 7 of these pieces. So if we refer to 7 of the pieces, that is 3 7 times, or 7 times 3, which gives us 21.
Thanks, Becca. That was a great video to help us remember about fractions of.
Thank you. Do we have callers? We have a caller coming in.
It's Luigi from EMHS, not sure what that is, 11th grade, EGHS, absolute values algebra.
Sounds like we have one of our own Emily Griffith students calling with a math question for Becca.
Okay.
Hello.
Hi, who am I speaking with?
Luigi. This is Luigi.
Hi, Luigi. What question do you have?
I have a question about absolute value.
About absolute value?
Yes.
Okay, what's your question?
So, I have this thing that says solve the equation, check your answer, and it's got the absolute value of -6x.
Sorry, the absolute value, say that one more time?
The absolute value of -6x
Okay,
equals 24.
equals 24. And you have to solve and check your solution?
Yes.
Okay. All right, so if you can cut to my screen, I can show you. One thing that's important to know about absolute value is that absolute value means the distance from 0. So just, this is Luigi's question here with the absolute value of -6x equals 24, and I'll get to that in just a second. If we have the absolute value of x equals 4, so I'm just kind of giving an example. What that means is that whatever x is, it's going to be 4 spaces away from 0. And so solutions to this are +4, or whenever you, so if you look on the number line, +4 is 4 spaces away from 0, and -4 is the other number that is 4 spaces away from 0. And so this most absolute value equations have 2 solutions to them because it's the distance from 0. We have the negative distance from 0 and we have the positive distance from 0. So back to Luigi's question, the -6x equals 24. Whenever we solve absolute value equations, we begin by writing 2 separate equations so that we can get both of our answers. So the first equation I'll write is -6x equals 24. So just how you see it without those absolute value bars. That's the first equation we write. The second equation, just like my example that I showed with absolute value of 4, the second equation is going to be the opposite of that. So like +4, the opposite of +4 is -4. So the way that I will write that is -6x equals -24. And so I have two equations that satisfy my absolute value of -6. So what we'll do now is we'll solve both equations, and then we will check our answer for x. So to solve for the first equation, to get x by itself, we want to divide both sides by 6, or -6, sorry. And -6 divided by -6 gives you 1. So on the left, you're left with just x. And 24 divided by -6, you get -4. And then that's our first equation. The second equation, same thing. To get x by itself, we'll divide by -6. And on the right side of the equation, we now have +4. So it just so works out that it's actually the same as the example that I gave. Now, Luigi said that we needed to check the work. So to check the work for any equation, you always want to go back and put your answer into the original problem. So we'll start with our first solution, which is x is -4. So we have -6 times -4 equals 24. And what we want to see is if that makes the equation true. If it makes the equation true, then we know we have a correct answer. So inside the absolute value bars, we'll simplify that. We have -6 times -4 gives us 24. And so this part of the equation is true because the absolute value of 24 is 24. 24 is 24 spaces away from 0. We'll check our second solution. So we know that the x is -4. We know this is a solution. We'll check our second solution of x equals 4 by, again, plugging it in and replacing our x variable with that. So, So we have -6 times +4 this time, which gives us 24. And we'll simplify what's inside the absolute value. So -6 times 4 gives you -24. And -24, this is true, -24 is 24 spaces away from 0. And so therefore, both solutions check out. So equation solved, equations checked out. Did that answer your question, Luigi? Are you still on the line?
Yes, thank you very much.
You're welcome. No problem. Anytime. Call back anytime.
All right.
All right.
All right. Do we have any other callers? Remember, you can also tweet your questions at EG Homework on Twitter.
Now, we'll see what we can get up going here.
If you are feeling shy, the best way to do this is to Twitter, or you can email us. Again, that's at EG Homework, or you can email us at homework@emilygriffith.edu. And those are really good ways to do it, especially if you have a long question or if you're shy and you don't want to talk on the phone on TV. That's totally fine. We're happy to answer your questions from anywhere. So if we have no questions right now, let's look at another Back to Basics. Let's look at Homophones, Back to Basics with Whitney. It's and it's.
Our next Back to Basics lesson is again on homophones, words that sound the same. We're dealing with its and its, one with an apostrophe, one without. This is a little tricky because usually apostrophes show us possession, but we also know that they take the place of letters. So this is one of those rules you just kind of have to memorize. This its with no apostrophe actually does show us possession. It tells us that something belongs to it. This one has the apostrophe and it means it is. So let's say we saw a dog and we don't know if it's a girl or a boy. We could say its bowl of water is too full and it is going to spill. The bowl of water belongs to it. We don't know what the dog is, but we know that it is going to spill. its bowl of water is too full and it's going to spill. That should show you how to remember the difference between it's without an apostrophe and it's with an apostrophe. Okay.
Next question.
Okay, I think we have a Twitter question. Let me see if I can
Oh, it
find
looks like it's a math question. Can
Okay.
we check out our tweets? The question says, can you help me better understand the FOIL technique? I can never get it right. So the FOIL technique is not my favorite technique, but it works. And I'll explain it, and then I'll show you possibly a better way to do the FOIL technique. What FOIL is used for is to multiply binomials together. And it's one of my students, the way he put it, I loved it. He said it's a fancy way of distributing. When you distribute, so let's see, I'm going to pick two binomials, simple ones just to show you this. So x minus 2 and x plus 3. So FOIL is a technique that is used to multiply the binomials together without forgetting to multiply any parts of it together. So FOIL, what it stands for is front, outside, let's see if I can squeeze it in there, inside, and last. And so to do this, so the front terms, and I'll do these with different colors so that you can see what I'm talking about. So the front terms are these two first terms here, front. So we're going to multiply those together first. So what we'll do is we'll take x times x, which gives us x squared. So we did the front. Then they want us to do the outside terms, which, I don't know why that keeps doing that. Okay, so then we have x and 3, which are our outside terms. So we'll multiply those together by doing 3 times x, which is just 3x. Then the inside, so not the 3 anymore. It's negative 2. It's the 2 inside terms, and x, so minus 2x. And then last. So 3 and negative 2. So those are our last two terms. So 3 times negative 2 is negative 6. Then what we do is we combine like terms. So the 3x and the negative 2x, those are like terms. So we'll put them together. And we get positive x and minus 6. So FOIL it's a fancy way of distributing. It's a way of making sure that we multiply all of the terms together of two binomials. The only problem with this is that FOIL only works when you have two binomials. Binomials are, in case that you don't know, binomials, this prefix bi means two, like in bicycle we have two wheels. So binomials are two expressions that have, or an expression that have two terms. So the problem with FOIL is that it only works for binomials. So I wanted to show you another technique if you're having trouble, and that's called, I call it the area model of multiplying, and you may have seen it with whole numbers, such as, let's set this square here. I'll set this up and show you an example. So we're multiplying together x minus 2 and x plus 3. So I set my binomials up on the side. And we know that area is length times width. And so this is why we call it an area model, is that we're going to now find the area of this square or rectangle here. So we'll take each part of it and multiply them together. So I'm going to take my x times my x, which gives me x squared, x times 3, 3x, negative 2 times x, negative 2x, and negative 2 times 3. And you can see that with the area model, you still get the same polynomial that we got earlier when we did FOIL. When you look on the inside, so you can see that we have x squared minus 2x plus 3x minus 6. Those will combine to give us the same polynomial. And this area model works for other things too. So you can always use the area model for whole numbers. So let's say I wanted to do 24 times 13. I could set the area model up like this, where I have 20 and 4 and 10 and 3. And we multiply and add our numbers together. So you can do it with whole numbers, you can do it with trinomials. It's definitely something that applies to more cases than just FOIL. But I hope that helps you understand FOIL a little bit better.
We have a caller coming in.
So hope that helps.
AKA Luigi.
So we have another caller coming in.
All right.
Where that's coming from.
Great. I think we've got a language arts question, so we're ready for that whenever you're ready.
Can you still hear me?
Yep. We're ready. Since this is our first live show, we do appreciate your patience. Hopefully we'll be a little bit more popular as time goes on.
We have a real caller, Cassandra from Emily Griffith High School.
Okay.
Algebra question.
Oh my goodness.
Okay, we have an algebra question instead.
All right. Waiting for the algebra question. Hello.
Hello, I'm calling because I'm wondering how I can graph y is less than x1 out of the dash or all this thing.
Okay, let me pull up some grid paper, and once I pull up some grid paper, I want to hear your question one more time. So,
Okay.
okay. So tell me your question. You want to graph an inequality?
Yeah, I'm graphing an inequality and I don't know, I'm confused on how to graph it.
Okay, so what's the inequality?
It says y is less than x plus 1. Like,
So y is less than x plus 1, and you have to graph it?
yeah, I graphed it, but I don't know if it's a dash line or a solid line, and I don't know if it's like above or beyond, like shaded.
Okay, let me see if I can help you out. So when you're graphing an inequality, we want to start with your regular four-quadrant graph, sorry. And were you able to graph the x plus 1?
Well, I went just like up 1 and then up 1 over 1. I don't know if that's right.
Perfect. So you started then by graphing the equation, the y equals x plus 1, where our 1 is that the y-intercept, and then the slope is 1. Okay, so you got that far.
Yeah,
So,
but I don't know that dash or solid and where to change above or below.
wonderful. Okay, so what Cassandra is saying is that she's gotten the graph already she knows where her boundary line is going to be, which is you graph y equals x plus 1. And so she has her boundary line, but she's not sure about if she's supposed to have it dashed or solid and where to shade whenever you're graphing an inequality. So general rules, if you have just a regular less than or greater than, we're going to have a dashed boundary.
Okay.
And then if we have less than or equal to and greater than or equal to, then we have a solid boundary. So based on that, which would you think that this one is? Is it solid or dashed?
This one will be dash.
Yeah, good. You got it. So because we are just a regular less than, we're going to have a dashed boundary.
Yeah.
And then the way that you tell where to shade is by looking at how does your y value relate to your boundary. So your boundary is at x plus 1, and it says y is greater than or less than your x plus 1.
It's
So-
less than.
Okay, so if your y is going to be less than your boundary, your x plus 1 boundary, do you think you would shade above or below that graph?
Well, if it's less than, then it's probably like in the negative, like below.
Mm-hmm, you got it, exactly. We want our y value to be smaller. Nice.
Yeah.
Very, very good. So if it
Yeah.
said greater than, where would you shade?
I would shade above.
Wonderful. Awesome. Did that help, Cassandra?
Yes, it is.
Thank you so
Thank
much
you
for
so much.
calling.
After this,
All right, thank you.
Thank you.
All right, bye-bye.
Bye.
All right, that was great. Remember, you can always call in and ask your homework questions or text or email or tweet. We're going to look at another Back to Basics video, this time focusing on more fractions of.
okay, Dave's coming in and you're going to do a little thing with Dave.
Do you want me to introduce Dave?
Sorry about that. We'll go back to that video next time so that you can see it the whole way through. Sorry about the technical difficulties.
We currently have our principal for Emily Griffith High School with us here. This is Mr. Dave Daves.
Actually, I prefer David.
Okay.
If you don't mind. David Daves. Well, thank you very much for joining us. If anybody is out there watching, I just want to give a plug for Emily Griffith High School. It is a wonderful high school. If you're looking for a place to go to school to have just exceptional teachers, really one-on-one attention, incredible things including, those are real bricks, not fake bricks behind us. It is fantastic. If you want to go to a school where a teacher actually looks like a teacher, look at this. She is not dressing up like this just for this show. She comes with these glasses every single day.
She does.
I also know you're thinking, Rebecca, she's probably tall. No, look at this. All special effects.
I almost fit on the whole screen
Right.
without.
Right here. You could put her in your pocket and take her home at the end of the day to help you with your homework. At any rate, we would love it if you came to Emily Griffith High School. We're really happy that you guys are here doing this for us. Thank you very much. Are we paying you?
Yeah.
You're not supposed to say that. Working double
No,
hours.
it's all, no.
Thank you very,
Charity
very
work.
much. And I think that's it. I've got some questions.
Okay. What's your question,
Well,
Mr.
I don't know,
Daves?
do you have any waiting for you?
Do we have any callers? No. Okay. What's a question you have, Mr. Daves?
Well, so my daughter is in her geography class. They're having a discussion today about what people do in different cultures. And one of the things that was brought up was the population policy in China, and specifically about limiting it to one children, and often, if it was a boy, not having the child. And their teacher is saying that we have to respect other people's cultures. My daughter is saying there's a difference between right and wrong, whether it's cultural or not. Whitney?
Well, I think that definitely her teacher has something going there. When we are dealing with different cultures, we all do things differently. A lot of people in America eat meat and cheese together, whereas other cultures, that's against their religion, and we need to respect that. I do think, however, that the policy has changed in China, so that may be something that your daughter could appreciate now, that they've actually changed that. They're a little more progressive. But like I said, I think that her teacher's on the right track. There's all kinds of cultures, religions, and styles of living, and I think that we need to respect and kind of sometimes have an agree to disagree kind of attitude.
Was that the culture, or is that the Chinese government policy? That's my question.
It may be the government policy, but
Do we need to respect that?
probably, since they are one of our allies. We don't want to start a war with China because of our differing beliefs. So yeah,
The producer's calling me off.
I would tell your daughter to probably just, you know, do a little bit more research, and maybe she wants to visit China sometime to kind of see how things go.
Becky?
Me too. I'll go.
No, about what, do we respect the culture?
I agree. No, I agree. But I mean, I think it also is a government mandate. So then, of course, they are related. But yeah.
So what if the culture institutionalizes slavery? Is that something we respect?
Probably not, but you know, since we are not elected government officials, it's hard to speak for them. I think that they have a lot of really hard decisions to make, and I don't want to be the one making them. So, not to cut you off, Mr. Daves, but I think we have some questions coming in.
Thank you guys for having me. I'll let you go.
Yeah.
Of
Emily
course.
Griffith High
Anytime,
School.
come and hang out on the show.
Bye.
Bye, thanks. All right, great. So questions via Twitter, maybe?
Oh,
Or-
text questions. I see some text questions.
Oh, okay. Oh, the voice one. Okay. Let's see. All right. Oh, just like I said, we have a question here that's asking about the difference between all right, one word, and all right, two words. So if we can take a look at my screen that I'm working on with my computer here. These are the two phrases that are being questioned, okay? So the first one here, two words, is basically two words. If everything is going correctly, it would be this first one. The second one is kind of a slang term, okay? You guys can go off my screen for just a second there. So the first, like I said, the first two words there, it's saying everything is correct, everything is okay. The second one basically means acceptable, okay? It's kind of hard to tell the difference between the two here, but as one word, sorry, I'm kind of messing you guys up. Written as one word, like I said, it's slang. It's not really a correct thing to use. You want to use the two words. Everything is okay. It is all correct. It's all right. I hope that answered your question. If it didn't, please send us another text into our Google account here. I also have another text question here that's asking about getting through 5-paragraph essays and any tricks or tips for that. So first of all, I would say that the 5-paragraph essay is a great way to write an essay because you've got your introductory paragraph is 1, your 3 body paragraphs in the middle can talk about your main points, and your final, your 5th paragraph is your conclusion. And while you may not always write like this, especially in college, it's a great way to start. I like to think of this 5-paragraph style as an essay sandwich. Your first paragraph is the top piece of bread, your last paragraph is the bottom piece, and those 3 body paragraphs are kind of the meat of the essay. You can introduce your topic in the beginning and kind of preview what those body paragraphs are going to include, and in that conclusion, it mimics the introductory paragraph. So just like you would have 2 very similar pieces of bread holding that sandwich together, your intro and your conclusion are also going to be very similar. They're going to say what you just said. In a 5-paragraph essay, you want to make sure that you transition between your paragraphs, and also that you follow a process. All writers, all published writers, they don't just write something and that is the final product that we all read and love. All of our favorite writers have editors. They go through a brainstorming process, a pre-writing process, then they write, their editor looks at it, they revise, change things, add things, maybe even remove some things. And everybody needs to go into essay writing with that in mind. You want to make sure that the more work you do at the beginning of an essay, the less you're going to have to do at the end. So if your teacher requires you to show your pre-writing and your first draft, really put a lot of effort into that, because then if you have a peer editor or if your teacher helps you edit your paper, you don't have to go and do a lot of work at the end. So make sure you really think about your topic and brainstorm either on paper or kind of in your head. Write out those 5 paragraphs as well as you can, and then ask your editor to help you to make a good final product. But make sure you follow that process. I hope that answers your question. Again, if it doesn't, feel free to text or email or tweet back.
Speaking of, we have a call coming in. Okay.
All right, I guess we have another English question from a caller. So if you just bear with us for a moment while we get that in.
Hello?
Hi.
Hi. My name is Bob.
Hi, Bob.
I have a question about the Catcher in the Rye.
Okay.
I keep hearing that the red hunting cap is a symbol. What is it a symbol for? What does it represent?
Well, do you know what a symbol is, Bob?
It's supposed to represent something else. Like it's something that isn't the other thing, but it represents it.
Right. So like how in the United States we have the symbol of the eagle to kind of represent freedom because it can fly and do all of those things. So you're absolutely correct. A symbol does represent something bigger or something else. So any ideas? I mean, have you finished the book, The Catcher in the Rye?
Yes.
Okay. So do you have any thoughts just off the top of your head about what maybe that cap could represent? I know you're calling in to ask, but I'm just wondering if you have any ideas.
I keep hearing that it has something to do with comfort, or possibly it's this comfort item or something with like childhood, something
Right.
like that.
Okay, and do you remember the background with that hat? How long he's worn it or anything like that?
I think he got it in New York, didn't he? Right before the beginning of the book.
Okay, and then the whole book kind of deals with him living his life and getting to know all of those things about himself and kind of growing up, right? Is that right?
Yes.
Now, in that story, does anybody else wear that kind of hat, or does anybody give him grief about that hat? Do you remember?
I think his friends sort of make fun of him for wearing it.
Okay, so a lot of people, and symbols are kind of up for question, they're up for interpretation, and that's why I kind of wanted to get your ideas about it. Wearing something so bright and unique kind of shows us Holden's individuality. He's the only type of person wearing that hat. And the color is kind of significant as well. It's very bright, which is kind of a contrast to his personality. But also, someone in that story has red hair, do they not?
Oh, that's right. His little brother, the one that died.
Okay, exactly. So you've got that similarity between the colors and also Holden's own unique personality, his individuality. So a lot of people believe that the red hunting cap is a symbol of individuality and nonconformity and everything that Holden is looking for, that non-phony side of humanity. I hope that answers your question.
Yes, thank you very much.
Great.
Goodbye.
So it looks like we have, we have a quick question. So somebody commented on the mural behind us. They said, that's a cool mural. Who did that? So do you want to tell us a little bit about the mural? I know you know the student.
Sure, yeah. One of our students actually spray painted this, and I guess it's kind of a good example of positive graffiti. We commissioned him. His name is Jim Salazar, and he's a great artist. We actually have a little art show going on in our coffee shop for Emily Griffith tomorrow, Thursday, during the afternoon. All of our students here at Emily Griffith should definitely check that out. And you can see some of his other art on display in that art show in our cafe. But yeah, he did this awesome mural here in spray paint, and we think it's pretty cool.
Yes, we do. There's another question on here. It looks like it's a language arts question again.
Okay, a tweet?
Yes.
Why am I not seeing it?
The question is, what are examples of subordinate conjunctions used to combine clauses?
Okay. Okay. Maybe give me just a second on that. Subordinate.
While Whitney's doing this, thank you. I wanted to thank you guys for calling, and thank you for sending in your tweets and texts. And please feel free to keep doing this. And you don't have to tweet us during the show. You can tweet us before the show, and we can answer your questions, later on the show. So thank you again for doing that for us.
Okay, I can't find the question on mine, but if you would read it to me again,
so it
Becca.
says, what are examples of subordinate conjunctions used to combine clauses?
Okay, there are a lot of subordinate conjunctions. A lot of them kind of can sometimes be prepositions, like prepositional phrases, like after or although or rather than or since. They're not your typical conjunctions like and, yet, but, for, so, or, but they kind of introduce or change the way that the sentence is going to work. And so it might be something like, after I sneezed, that would be your subordinate clause. After is your subordinate conjunction, okay? Or once we went to the store, we bought some things. That once is a subordinate conjunction. Like I said, there's a long list of these and different ways that they can be used. So you might look in your language arts textbook or even try Googling if you want to make sure that you've got that right. If you have a specific question about your homework using these subordinate clauses, I'll be happy to answer them. But there's just so many different types of subordinate conjunctions, it'd be kind of hard to discuss them all right now. But please call back or email or tweet back if I didn't fully answer your question.
It looks like we have another question on Twitter. It looks like everybody's using Twitter. Works very well. So the question is, how do you find the volume of a cylinder? So if you cut to my screen, I can show you how to do this. So the shape, and forgive my rough drawing here, but the shape that I've drawn, it's a cylinder, kind of like a pop can. That's what a cylinder is, where it's a circle, and then you have height to it. So the formula to find the volume of a cylinder is pi times the radius squared times the height. So when you have a cylinder, you need to know these are your two variables, and you need to know those two things. You need to know your radius, or be able to figure out your radius, and you need to know your height. So the radius is the distance from the middle of the circle on one of your surfaces to the edge. And so I'm gonna guess that this is a pop can. I'm just gonna say, let's say it's about one inch. So our radius is 1 inch. And then a pop can maybe is about 5 inches tall, maybe 6 inches. So our height. So we need to know that height, and you need to know the radius from the center to the edge. So once you know those two things, it's pretty much you're just plugging in your values for the radius and for your height and multiplying them together to find your answer. So we still have pi, and then our radius in this cylinder is 1 inch. So we will plug in 1 for r, and that's squared. And then our height is 5 inches, so then we'll multiply by 5. And so we want to, order of operations wise, we want to do the exponent first. So we have pi times 1 squared, which is 1, times 5, which is 5. So the way that we write our answer is with that 5 in front of pi. That's usually how it's written. And then we, of course, because we're finding volume, we don't want to forget our units, which in this case I measured in inches. And so our units are inches and then cubed because we're measuring volume, or three-dimensional. So hopefully that helps with finding the volume. I just gave one example, but if you have something more specific, I'm happy to answer that question, so just let us know.
All right, we're going to look at another Back to Basics video. We'll be doing these occasionally to kind of show you little quick ways to kind of remember some of those basic math or language arts skills. Our next Back to Basics lesson deals with homophones, words that sound the same. We're talking about the two yours. This your means belonging to you, your dog, your book, your school. This your has an apostrophe in it, so we know that that apostrophe has to take the place of the letter A. You are. You are going to work, you are going to school. This sentence illustrates the way to use both of the yours. Aren't you glad you are not grounded like your brother, the brother that belongs to you? Aren't you glad you're not grounded like your brother? Hopefully that can help you remember the yours. All right. I hope that Back to Basics video on the different types of your helped you out. And remember, we'll be doing other homophones and things like that. And if you have any specific questions, please ask away.
Yeah, we can always do a segment on something that you've been wondering about. We're happy to do that. So let us know. I'm looking at another question. It's a text, and it asks, can somebody explain me the Pythagorean theorem formula? I just know that it is a square root or something like that. And I can't see the rest of it. Another question, how much time? I'll answer that second question in a minute, but let's go to the Pythagorean theorem. So if you go to my computer screen again, the Pythagorean theorem, the formula is a squared plus b squared equals c squared. And what it's used for is to find missing side lengths of right triangles. So, apologize for my rough drawing here, but so let's say I know this side length is 3, and then my other side length is 4, and my hypotenuse for it's the long line that connects the right angle, so the hypotenuse. This is one that we don't know, so we'll call it x. So this is just an example on how it's used. So hypotenuse. All right, so to use the formula, we choose our two sides and we plug them in for A and B and C. So if we put this side as A and the side as B. Doesn't matter which one, but what does matter is that your hypotenuse is C. So we're going to plug in the first side, 3. So 3 squared plus, and then B squared, which we said B is 4, so 4 squared equals C squared, or X squared, either one. But that's the side that we don't know. So we're going to use the Pythagorean theorem to help us find that. So to solve, we have 3 squared, which is 9, and then 4 squared, which is 16. And if you want to hear more about squares and square roots, feel free to ask. I'm happy to explain. Equals C squared. And then we'll add them together. So 9 plus 16 gives us 25. And we have 25 equals C squared. And here's the square root that you were talking about. To find what C is, and not just C squared, we have to square root both sides of our equation. So we're going to take square root of 25, and then the square root of C squared, which will give us just C. And then lastly, square root of 25 is 5. So our missing side is 5 units long. And that's what the Pythagorean theorem does. It tells us, or helps us, find missing side lengths of right triangles only. These doesn't work for every type of a triangle, just right triangles. So I hope that helped a little bit.
All right, we're actually going to look at a commercial now, and this is for our school, Emily Griffith. We have a high school and a technical school, and if you're interested in what we do, please come by and see us.
I love everything about working on cars, especially the finished product when I'm done. And when it pops and just everything looks beautiful.
It's relaxing for me. You're just focused on that car because all your attention has to be towards the engine.
We have the auto collision program, which is dealing with mainly the structural repairs of a collision accident. Then we got the auto mechanical portion of it, which is all the repairs of the engine, drivetrain, chassis parts, and stuff like that.
In auto body, you get to learn how to use some cool tools. You get to learn how to use the flame torch, how to use the plasma art cutter, welding. And in tech, you learn how to diagnose cars.
You're learning everything from engine repair to transmission repair to electrical, suspension, brakes. It's really hands-on. I mean, you do a little classroom work, but for the most part, you're out there and you have your hands on the cars.
They're offered morning, day, nights to fit anybody's schedule, anybody's work schedule to their convenience.
That's right, right?
Our course offers the same college curriculum, NHF certification, ASC certification for a third of the price.
For me, it was all about the price point. You know, I didn't want to be in debt when I came out of school. I kind of wanted to start off ahead as opposed to start off behind.
We have funding for grants that can help the students get into our program.
I qualified for a grant, and it basically cost me nothing to come to the school.
You learn everything here. I mean, from 30 grand to 6 grand for this program, I mean, it's kind of a no-brainer.
All right, as you can see, we offer all kinds of different opportunities here at Emily Griffith.
It's the reason it's called Emily Griffith Opportunity.
Yeah.
For sure.
So I think we've got another caller.
From North High School, I believe.
Again, we thank you for your patience for our first show. Oh.
Hello.
Hi.
I have a question about point slope form,
Oh,
the
math
linear equation.
Okay.
What is it? How do I use it? Like, what would I use it for?
Okay, point slope form. If you go to my screen again, point slope form, first I'll show you what it is, and then I'll tell you what it is, and hopefully this helps. So point slope form is a little bit less common. One that's probably most familiar is y equals mx plus b, or slope intercept. But point slope form is y minus y1 equals m, or the slope, times x minus x1. And what it's used for is actually, the name kind of tells you what it's used for. If you know or are given a point in the equation or graph or whatever it is, you're given a point and you know the slope, then what you can do is plug in those numbers and you have an equation for your line. I'll give you an example. Oftentimes, if you have, let's say you're given 2 coordinates, this is good to use point slope form when you have 2 coordinates, because we can easily find the slope from these 2 points. The slope is represented by m in our equation, and to find the slope, you find the change in y over the change in x, or you might have heard rise over run, or y1 minus y2, all of the same thing. But what we do is, and I can talk more about this in a back to basics, but we take our y values and we subtract. So our y2 is 5 and our y1 is 3. And those go over our x1 and our x2. And so our x2 is 4 and our x1 is y. So we'll subtract and we'll simplify. So I have 2 over 2, which means my slope is 1 in this case. So what we can do is plug in our slope of 1 and one of our points in order to find the equation of the line. So my equation would be y minus and then y1. So just pick one of your y values. So y minus, I'm going to just pick the first point, but it doesn't make a difference. So we have y minus 3 equals, and then our slope we found is 1 times x minus x1, which is 2. And so we can use this equation for a couple things: to graph our line, to solve inequalities, or sorry, not inequalities, solve systems of equations, things like that. But point slope is best when you know a point and you can find the slope. So hopefully that helps a little bit.
All right. Thank you.
You're welcome.
I'm just going to take this. All right, so this is the official end of our very first homework hotline. Be sure to tune in again every Wednesday from 4 to 5 Mountain Time for homework help right here on Comcast Channel 22. Remember that there are several ways that you can contact us. You can call, text, email, or tweet, so no excuses. No reason to sit around and wonder, how am I going to do this homework on my own? So thanks for watching, and we'll see you next week.